Regarding the purpose of this project, we have a couple of stipulated objectives. First, we'll have to visualize our two perspectives to achieve and their central characteristics. In this case, our ESP32 microcontroller. With this chip, we will implement both ideas. Our first objective will be to design and develop an embedded system capable to collect temperature, humidity, and luminosity. This data is going to sensors, sending those measurements to our ESP32 chip and design an activation system with a relay module for a light source. Now, in our second task, we'll have to use our ESP32 chip to design and synchronize a web server using its local flash memory and the MQTT protocol, and with it, build an interface to displace, monitor, and manage the data previously collected from our embedded system, and with it, activate the light source, in this case, a 120 volts bulb. Now, my teammate Julian will explain the code source.
Okay, now I'm going to explain the code. The first part is the part that we include all the libraries to control the DHT11 sensor and to establish the MQTT connection with the Adafruit. Here we have the pins. We declare all the MQTT variables like the server, the port, the user, and the key. These are all the variables that we are going to use to measure the data. And here is all the variables that we are going to use to connect and tell the ESP where it should either publish or get the information. If it publishes, it means that it's going to send the information from the ESP to the server. And if it subscribes, it means that it's going to receive the information from the server. Here, just declare the input and outputs of the relay and the LRD. All things about the serial and the internet connection. Here we have just a small security check for the connection. And here is the subscription, in which we are only thinking, or well, we are only receiving the information from the field that is called relay. And based on the message in the server, we are going to decide whether we turn on the relay or we turn it off. Next, we publish the data that we recollected from the temperature sensor and the humidity data. After that, we calculate the values of the LRD and we convert them in a scale from 0 to 5, in which 5 is the maximum value and 0 is the minimum value. If it's 0, it means that there is no light, and if it is 5, it means that there's a lot of light. So based on that information, we are going to send it to the server. And with this, we publish the information of the lamp status. This is going to be done every 10 seconds. And then here is a small security check of the MQTT, in which we check if we receive an error code, and we can notify the user using the serial with the different meanings that a code can have. And that will be everything for the code.
As we can see now, this is the dashboard of the MQTT server. We are publishing three types of data: the temperature and humidity received from the DHT11 sensor, and the lamp status that is read from an LDR, light detecting resistor sensor. We are sending this information, so we are publishing to the server, and we are subscribing ourselves the toggle or switch that is on the screen that will change the state for a relay that when it is on, it will activate the 120 volt light bulb, and when it's off, it will turn it off by cutting all of the connection. Now we're going to do a little demonstration by turning off the relay. As we can see, the light bulb is turned on, is turned off, but if we put the toggle on again, it will turn on. The intervals of the data that is being sent and received is from 10 seconds. So when we switch the relay, it will take 10 seconds to the ESP to actually like send the information, and it goes to the ESP and also to the MQTT server.
Okay, so now I'm going to explain the circuit. We have the ESP32 connected to our laptop through this cable, and this ESP is powering the DHT11 sensor and the LDR as well, with 5 volts. And the DHT sensor is powered and grounded, and we obtain its output from his second pin from left to right, and it is connected to the pin 27 of the ESP. The output of the LDR is connected to the pin 34 of the ESP, and then we connected our two relay module, which is power and grounded as well from the ESP, and its pin in 1 is connected to the ESP 26 pin. This relay module is connected to one part of the cable, which is connected to the 120 volts, as you can see there, and the other part is connected to the light bulb, and it is normally open. Whenever the toggle relay is changed, the light bulb will turn on or off. And this is possible by the internal plaquettes that the relay has, and the light bulb is also grounded, as you can see there. So we will do again the demonstration, but I will turn off the light of the room. Okay, now the light bulb is on, and the lamp status is also on. So if we turn off the light bulb, the lamp status should change to off as well, since there is no light. And it has changed on the dashboard. If we turn it on again, we change the lamp status as well. After 10 seconds, the light bulb turns on and the lamp status change. And with that, we prove that the circuit is working.
Well, that will be everything for this demonstration. Hope you have enjoyed, and we'll see you again.